Since the question is asking us to find the rate of change in volume, we're going to begin by taking our formula and writing it so that we have a function for volume. So we have V, dividing both sides by P, equal to 8.31 capital T divided by P. Which is the same as an 8.31 TP to the negative 1 power. So we can do a little tree diagram to help guide us in what we need. We're assuming that we have the pressure as a function of time, lowercase t, and the volume as a function of time, and the temperature as a function of time. Now, don't confuse the capital T's and the lowercase t's. Capital T temperature, lowercase t time. So we need to find the rate of change in volume. So we're looking for dV dt. We have V as a function of temperature and pressure. So we can do two derivatives. We can do the derivative of V with respect to T, temperature, and we can do the derivative of V with respect to P. The temperature, we're assuming, is a function of time. And so we could also do the derivative of temperature, capital T, with respect to time, lowercase t. Now that is nothing more than the rate at which the temperature is changing. Now, although we don't know the function for that, we know the rate at which the temperature is changing. So we can use a specific value for d capital T over d lowercase t. And likewise, we can find the dP d lowercase t. So our formula for dV dt is going to be partial of V with respect to capital T times the derivative of capital T with respect to time plus the change in volume with respect to pressure times the change in pressure with respect to time. Now, these two we're going to need to actually do, but the other two we're given. In fact, I'll go ahead and write those down. The change in temperature with respect to time is given right here. Now remember, pay careful attention to the terminology. Since it's increasing, that will be a positive 0.05. And likewise, the change in pressure, it says right here, is increasing at 0.09. So that also would be a positive 0.09. Okay, so now we need the derivative of V with respect to T. Now here is our formula. Since T is in the top, it's just this constant times T. So the derivative would be the constant, which in this case would be the 8.31 over P. To do the derivative of V with respect to P, we'll come over to this one and use the power rule. So we'll take the minus out front, leave the T alone, and then reduce the -1 to a -2. The only thing that remains, other than actually typing it into our calculator, is to insert the values. So here, for pressure, we're going to use the 27 ahead and put the two signs together and just make this a minus. And the temperature, 295. The pressure, 27. And of course we need to get that typed on our calculator. Now this is where using a TI-84 is advantageous, because you can pretty well type exactly what you have written on the TI-84. And I'm pretty sure that comes out to be negative 0.287.